Hello everybody, welcome to Mongojastro. In this video, we are going to discuss about some numericals based on the AC fundamental, based on the DC network theorem, or simple circuit analysis from problems and the DC machine. Okay, and also a transformer. So let's start with a simple circuit analytics question. So find the current through 4 ohm resistor. This is the very important question and most common and most easiest. Okay, here you will see that 1, 3, 2 and 4 resistances are connected with a 10 volt battery. We can find the current through this 4 ohm resistance. If it is the I2, we have to find out I2, and you can say that 10 volt battery can supply the main current I1 through this circuit. Okay, now I1 can divide into two part. Here is I3, or you can say it is I2. So now we can find this I2 by several methods, by Thevenin's theorem, by Norton's theorem, or by simple circuit analysis, because it is a simple circuit. So if we are going to solve this question by Thevenin's theorem, then we can make this 4 ohm resistance open, and then we can find out VTH, and then we can find out the RTH, that is the Thevenin's resistance. Then we can find out the IL. Okay, but by the Norton's theorem, we can also solve this by make this 4 ohm resistor short, and then we can find out the current, Norton's current, and the Norton equivalent resistance, all these things. Okay, but here it is preferred that don't go with the theorems, you just simply apply the current division rule. Okay, so for current division rule, we have to find out first, we have to find out that how much current, that is the main current I1, is supplied by the 10 volt battery. Before that, we can simplify this circuit, that is the series parallel technique. So if we simplify these resistances, then these 4 ohm and 3 ohm are in series, they are in series. That is the I2 is flowing through 3 ohm as well as the 4 ohm. So we can, if we simplify this, then we are getting 4 plus 3, 7 ohm, as they are in the series. So this is the 7 ohm. Okay, this is simple 1 ohm, this is simple 2 ohm. Now, and 10 volt is connected over here. Okay, now here the circuit is what? Now 2 and 7 volt at ohm are in series, parallel. So what is the equivalent? So that is the 2 parallel 7. So what is the R equivalent? So if we solve this, so 1 by R equivalent is equal to 1 by 2 plus 1 by 7, and you can solve it. 14 is your LCM, then 7 plus 2, that is the 9 by 14. So R equivalent become 14 by 9, 1 point something ohm. Okay, it is almost 1.5 ohm. Okay, now so if we again redraw this circuit, then for 2 and 7 we are getting the resistance as, this is your 10 volt as it is, this is your 1 volt, keep as it is, and these resistance become 14 by 9. Now now, so this is the 14 by 9. Why we simplify this? Because we have to find the current I1. Again, I1 is flowing through this, I1 is supplied by this battery. Here also I1 is supplied by this battery. Then the current is 10 divided by 1 plus 14 by 9. That is the 10 divided by 23 by 9. That becomes 90 by 23. So that is the current supply by 10 volt battery is equal to what? 90 by 23 ampere. Now these 90 by 23 ampere, that is the 90 by 23 ampere current, is divided into two parts. One is this, another is this. Okay, so 90 by 23 ampere current is flowing through 1 ohm resistance. Then from here it can divide in two parts. One is going to the 2 ohm and another is going to the 7 ohm. Now we can easily, so I1 is equal to E by R. Again I am repeating this, that is the 10 by 23 by 9, that is the 90 by 23. 23 ampere. Okay, now here there is resistance R1, here is resistance R2, and a voltage source is connected over here. This is the main scenario because this is the redundant, because the current 90 by 23 ampere is flowing through this 1 ohm resistance. Now if we want to find out the current through this, then I1, then what is the formula? I1 become and the current supply by this battery is I, then it becomes I, that is the total current supply by this battery, into, we have to find the current through R2, then we can take the R1 in numerator and the total resistance R1 plus R2. This is your formula. Now again, you just apply this formula over here. So here the R1 is nothing but the 2 ohm, R2 is nothing but the 7 ohm, and R1 and I is nothing but the 90 by 23, and I1 become I2. So what is your finding? So I2 become I1 into, this is R2 is the 2 by R1 plus R2 is the 2 plus 7. If you ask that the current, find the current I2 from here, then I2 become what? I2 become the total current I into R2 by R1 plus R2. I think you got this, and it is a simple current dividing rule, current divide rule. So it is I1 is what? 90 by 23, that is the total current supply by the battery, into 2 by 9. 9 10 90, it is the 20 by 23, that means the current is 0.86 ampere is current which is flowing through the 4 ohm resistor. So the current flowing through the resistor I2 is equal to 0.86 ampere. This is a very simple question. So go to the next question. So the next question is that from the transformer, TF transformer. The number of the primary and the secondary turns of a single phase transformer is 330 respectively. That means you can draw a simple schematic of a transformer. Here the primary side is, here the primary side winding, it is 300, and the secondary side winding is, this is the 30 and this is the 300. Okay, and the secondary coil is connected with a load impedance of 4 ohm. Okay, it means that here in the secondary side the load is connected over here, that is the 4 ohm, secondary side 4 ohm. Okay, this is the load resistance, and obviously if there is no given data of the winding resistances and reactances, we can say that the windings have no such impedance, that is the no resistance or no the reactance. Now find out the turns ratio. It's a very simple question. So what is turns ratio? We can know that turns ratio, you can say it is by n, or you can say it by k also. N is equal to np, that is the number of turn primary by ns. Np is what? Number of primary side, primary turn is equal to 300, given ns is what? Secondary turn, that is the number of secondary turn, it is nothing but the 30. So it is, you can put the 300 by 30, it is become 10, or you can say that this ratio become, as it is a ratio, we can say this is become 10:1 is the turns ratio. Okay, now what the, so the first question is that is the 10, turns ratio is the 10. Okay, now second part, just change the color. Load impedance refer to the primary. Okay, that means that the load is the secondary side load is the 4 ohm. Now you can put the 4 ohm into the primary side. What happened? If ZP is the primary side impedance and ZS is equal to secondary side impedance, then ZP is equal to ZS. ZP is equal to, that is the ZS, that's secondary side impedance, into n square. That is the when the referred to the primary. If it is say that note, you can make a note. If it is given that referred to secondary, that means the you have to put the secondary side impedance over primary side. Secondary becomes Zp by n square. Okay, so here it is the refer to the primary, so it is Zp, that is primary side, is the Zs into n square. So what is Zs? Zs is the impedance in the secondary side, that is the 4 ohm is given, into n is 10, 10 square, that is the 4 into 10 into 10 is equal to 4 into 100 is equal to 400 ohm is the load impedance referred to the primary. So second part is 400 ohm is the answer. Okay, now third part, primary current if the primary coil voltage is 220 volt. Okay, so here the primary side coil voltage is 220 volt. Now the primary current is, so the impedance we got impedance as 4 ohm for 400 ohm, because secondary side impedance is now reflected in the primary side. So the primary current, that is the simple Ohm's law, V is equal to IR. It means that IP is equal to V by R, V primary by R. R means the here Z primary. Where what is the V primary? It is the 220 volt is given, and what is Z primary? Z primary is the 400 ohm. So 220 by 400 is the 0.55 ampere. So here the third point is 0.55 ampere. I think it is very easy for you. Now go to the now an alternating current. This is from AC fundamental. An alternating current is given by I is equal to 14.14 sine 377t. So I is equal to Im sine omega t is your the general equation for current, where Im is the maximum current and omega t sine, this is nothing but the omega into is t, nothing but the it is a angle. Okay, and the omega is the angular frequency. This omega is nothing but the angular frequency, and omega is equal to, we know that 2 pi into f. Okay, now you have to find out what the current equation. I is equal to 14.14 sine 377 t. Now you compare this equation, I is equal to Im sine omega t. Okay, now first find the RMS value of the current. Okay, now RMS value is what? RMS value is equal to Im by root 2, that is the maximum value by root 2. If Im is 1, and so RMS value is 0.707. Okay, so if you compare these two, then Im become what? 14.14, because Im over here is 14.14. So RMS become what? Im by root 2. That means the 14.14 by root 2, it become, I think if you calculate it, it become 10 ampere. So first part is RMS value is 10 ampere. Very easy. It is 12 standard question. The frequency. Okay, frequency means that this f. Now we can say that uh, omega is equal to here 377. Here you see again, you change the color. Here omega is equal to 377. So omega is 377 means 2 pi f is equal to 377. Then f is equal to 377 377 by 2 pi. That means it becomes 60 hertz. Again it is a very easy, is the 60 hertz. Now I am again changing the color. Now third part, this is the second part, this is the first part, this is the third part. Okay, third part is the instantaneous value at the when the t is 3 microsecond. Okay, acha 3 millisecond. Okay, so at t is equal to 3 millisecond, I is equal to 14.14, I is equal to 14.14 sine omega become 377, that is in radian 377 into, you have to find change it in the degree, that is the, you can multiply by 180 by pi into t means the 3, and is in millisecond, so it is become 10 to the power multiplied with the 10 to the power minus 3 to make it in second. So it is 14.14 sine, it become I think it is 64.8, I think it is sine 68.4, or you can calculate it 68 point sorry 64.8 degree. So it is the 14.14 into 0.9048, that is become 12.79 ampere. This is the last part, is the at instantaneous current at I at the 3 millisecond become 12.79 ampere. Okay, this become 12.79 ampere. Very easy question. So question 1 2 3 is completed. Now question 4, go to the next question. It is from the DC machine. A shunt generator delivers 450 ampere at 230 volt. That is the generator. The how can we draw the generator? Generator is drawn by a circle, and there two armatures are there. Here the two armature. So this is your G. G stands for generator. Is supply delivers 450 amperes. It means that we can connect one load where it delivers how much? 450 ampere of current. Okay, here it is the load. So this is at 230 volt. And shunt field resistance and armature field resistance are 50 ohm and 0.03 ohm. Okay, now the shunt field resistance and armature resistance, here if here is some armature, the armature resistance is 0.03. Now the how the shunt is connected, shunt is connected over here like this, field coil. So here this coil has some resistances. This is called the RSH, shunt resistance. Now this generator is generating a current IA, because IA stands for armature. Then it can deliver a current I to the load, and is 450 ampere, is supplying the 450 ampere at 230 volt. So this is at the load side. Here you can say that it is a load. At load side it is at 230 volt, it supplies 450 ampere, and here the ISH is flowing. So IA is equal to nothing but the IA is nothing but the I plus ISH. Here it is generator. Generating action means the current is flowing to the load, and for motor action it is the current is flowing through the armature. Okay, now this RSH. So what are the given data? That is the load current. Load current is equal to what? I is equal to 450 ampere. Now what is the armature resistance? RA is equal to armature resistance is equal to 0.03 ohm. Okay, shunt resistance RSH, this is the same shunt resistance, is nothing but the 50 ohm. Now what is ISH? ISH it become V by RSH. What is V? Is the 230 volt, and RSH is the 50, that is the It is 4.6 ampere is the ISH. Now armature current, armature current IA is equal to I plus ISH. That is the armature current which is flowing. One side is going to the ISH and another is going to the load or the sub or the where the appliances are connected, electrical appliances are connected. So I is the 450 ampere plus ISH is the 0. Sorry, I say 4.6. I say 4.6. That means the 456.6 ampere. This is the armature current. It's a very high current. Now, what is generated EMF? So now, generated EMF, that is the how much EMF is generated is equal to EG. It is generated by EG. E generated is equal to V plus IA into RA. So what is V? V is equal to 230 volt plus IA. IA is nothing but the 456.5 into RA is the 0.03. That is the 230 plus 13.63. It becomes 243.63 volt. You can cross check the calculations. Okay. Now go to the next question. Question 1, 2, 3, 4 is already completed. Now is question number 5. A 3-phase 50 Hz 6-pole induction motor. The motor has the pole is this. It is a from in 3-phase induction single 3-phase induction motor. 3-phase 50 Hz induction 6-pole induction motor runs at, so it is 3-phase IM induction motor runs at 950 rpm. Calculate the synchronous speed, the slip and the frequency of the rotor EMF. It's a very simple question. So it is, if you put some value in a formula, then you can got every question that asked. Okay, so the synchronous speed is denoted by ns. The synchronous speed is equal to ns is equal to 120 f by p, where f is the frequency and p is the number of pole. Okay, now frequency is the 50 hertz, so 120 into 50 by p number of pole is 6. That means the 1500, sorry, 620 110,000 rpm, 1000 rpm. There is the synchronous speed. Now the slip, that is the difference between the synchronous speed and the rotor speed by the synchronous speed. That is the slip. Yes, you should prepare the for the definition of the slip for your upcoming examination. S is equal to ns, that is the synchronous speed, minus nr, that is the rotor speed, by ns. So what is ns? Ns is 1000 minus motor runs 950, that is the nr, that is rotor speed 950, and this is by ns is 1000. So it becomes 50 divided by 1000. So 5 by 100 is the 0.05 is the slip. Very easy question. You can minutely go through the question, then you can answer. Then the frequency of the rotor EMF, very simple. The frequency of rotor EMF is the slip into frequency. So frequency of rotor EMF is equal to, it is denoted by FR is equal to S into F. S is what? 0.05 slip. Frequency is 50. So it becomes 2.5 Hertz. So this is the 2.5 Hertz. Slip is 0.05 and the synchronous speed is 1000 rpm. Always you should keep on your mind that synchronous speed and the rotor speed are not equal. If they are equal, then no slip is produced. Okay, so go to the next question, that is the a 4-pole 3-phase induction motor. Again it is the 3-phase induction motor question. A motor operates from a supply whose frequency is 50 Hz. Calculate the speed at which the magnetic field of the rotor is rotating, that is the rotor, simply rotor speed. So here P is equal to number of pole is equal to 4. I just change the color. Then and F frequency is equal to 50 Hz. These two things are given. Now we have to find out the rotor speed, that is the NS. NS is equal to 120 F by P. Already I have discussed in the previous numerical. That is 120 into 50 by P is nothing but the 4. So it becomes 1500 rpm. So these become 1500 rpm. Okay, first part. Now go to the second part. Second part is the speed of the rotor when slip is 0.04. Very simple question. So nr is equal to ns into 1 minus s. So ns minus nr by ns is equal to s. So ns into s is equal to ns minus nr. Here nr become ns minus ns into s. So taking ns common, 1 minus s is your nr. From here we can derive this formula. So what is ns? Ns is nothing but the 1500 rpm, and 1 minus sleep is when sleep is 0.04. 0.04, that is the 1500 into 1 minus 1.04 means 0.96. So it become 1440. Just wait, I'm calculating. 1 minus 0.04 is equal to 0.96 into 1500, it is 1440 rpm. So that is nr is rotor speed is slightly lesser than the synchronous speed. Okay, now this become 1440 rpm, and this numerical is very much important for your upcoming examination. Then the third is the frequency of the rotor current when slip is 0.03. Okay, so fr, again I am changing the new color of the pen. So nr, oh sorry, not on nr, what, the frequency of the rotor current when the slip is 0.3. So fr, rotor frequency, is equal to s into f. I have already discussed. So s is when the slip is 0.03, 0.03, and frequency is 50. So it is become 1.5 Hz is your desired value. Now fourth part is the frequency of the rotor at standstill. At standstill, slip become 1. So f r is equal to s into f. S is 1 into f is 50, that is the 50 Hz is the frequency of the rotor at standstill. So this is the 50 Hz. Okay, now already completed 4 questions already completed. Now next question is a 220 volt DC shunt machine. Acha, this is the DC machine, has an armature resistance of 0.5 ohm It's a very good question. If the full load armature current is 20 ampere, find the induced EMF when the machine acts as a motor, generator or motor. Fleming's left hand and right hand rule decide whether the DC machine is we are using it, it is used as a motor or generator. So as a motor, as a generator, you should draw the two diagram, then you can easily got the idea. So if first is as a generator, so as generator I have already drawn in the one previous lecture, or not lecture, on one previous numerical, that this is the generating action. Here this is the load where the current is supplied by the generator, alternating current source. This is your G stands for generator. Now IA, that is the armature current, is supplied by the armature. This is the IL which is flowing through the load which we are using, and here one shunt resistance are there, ISH, shunt field, that has a shunt resistance RSH, and for that RSH, ISH is flowing through it. Now as generator, as if it is treated as generator, then V is equal to what? 220 volt. Okay, now IA, that is armature current, is equal to 0 point armature resistance is armature current is 20 ampere. It is the armature current is 20 ampere. 20 ampere. Armature resistance RA is equal to 0.5 ohm. Here if we draw armature over here resistance, it is the 0.5 ohm. Okay, now EG, generated EMF, EG is equal to V plus IARA. This is the only difference, only plus and minus, and the for motoring action EB, there is the back EMF become V minus IARA. So V is the 220 plus 20 into 0.5, that is the 220 plus 10 is equal to 230 volt. Now changing the color. So now if it is it is a motoring action, so the motor is same diagram, only EM is there, that is the motoring action. Here the armature are there. Now this is your supply voltage, 220 volt supply, 220 volt. Okay, now here the shunt resistance is again, here also shunt resistance RSH is equal to, again it is 20 ohm, not 20, sorry, shunt resistance not given, it is a shunt resistance. So the action is where the supply voltage, that is the I armature is the armature current is flowing through the armature, and for generating action the armature current is generating by the armature. So here IL, load current is flowing which can go through the armature, and then armature current, when our current is flowing through the armature, then a field is induced, and obviously shunt resistance, some current ISH is also flowing through it. So shunt field and the armature current field are cut each other, and then it can run. So it is ISH. So as motor, everything is same. V is equal to 220 volt, RA is equal to 0.5 ohm, and IA shunt armature current is equal to 20 ampere. Now the EB, there is a back EMF. Here back EMF is produced, is equal to V minus IARA. What is V? It is a 220 minus 20 into 0.5. That is the 220 minus 10 is equal to 210 volt is the generated or back EMF. Okay, back EMF given by the motor. So up to this We are already we have discussed all the numerical. If you go through all these 7 or 8 numerical, then you can got the full marks. Okay. You just go through this numerical problems, and please share this video to your friends. All the best for the upcoming exam.